Yep, before the lecture, some stuff over here. For your assignment number 2, it has been posted. I would say the level of difficulty for assignment 2 might be slightly above the practice test. You can definitely do some interesting semantic analysis of Boolean variable. But that's a nice practice for you. But I do want to show you one thing which will be very beneficial for your projects, which is something for regression testing. I'll show it to you. Okay. So if you go to the starter projects for assignment number 2, for the assignment instruction, you can read it. There should be no surprise in terms of what should be done. It will be very similar to your programming test. You are pretty much familiar with it already. So if you, okay, give me a moment. I already imported the starter projects. Okay, I'll show you to you. Sorry, just bear with me. I'm going to launch Eclipse. And you will see that there is one extra folder this time for your usage. Okay, I'll explain that. Okay, good. So if you open the project there, you will see under the source, there is one folder there called Regression Testing. It's actually some regression testing script, which one of my TAs wrote when I was teaching 3311, the software design course, before the pandemic, about 2019 or 2018. I think the code there is not too poorly written. It's actually OK. So I'm going to show you the idea. It's really useful, actually, for you to consider doing regression testing for your project and maybe start practicing from your assignment number 2. And then you can feel free to adopt or just adapt the Python code to whichever way you like. But if you don't like Python, for example, feel free to rewrite it in another language. But the idea about regression testing is really the thing I want you to try. Okay? I'll show you how it works. If you want to run the regression testing script, you wouldn't do it from Eclipse. You will have to do it from the command line, which is quite easy to set up. I'll show it to you. Okay? So if you go to the command line prompt, okay, let me make it a little bit larger for you guys. Sorry about that. Let me try to zoom in. Okay, just a little bit more, and then I can show it to you. Okay. Hopefully that's big enough, right? I hope. Okay, good. So let's see where we are. So let's say, assuming that you store your starter project under Eclipse workspace, excuse me, that's the assignment project folder. And now I'm under source. The only thing you have to put by yourself is to export whatever latest version of your project is, the Java project, into runnable jar. Okay, put it there. And you can put whatever name you like. In my case, I just say my-solver.jar or whatever name you like. Okay. Once you have done that, so that will represent the current version of your software, and you would like to put some regression testing. By the way, can anybody tell me what's really regression testing? What does it really mean to perform regression testing?
Test for regression, that is to see that you didn't give it an issue before, then you fix it to ensure it never appears again.
That's true. And also, in addition to it, you want to make sure you always maintain a repository of test cases. Whenever you try to introduce a new change to your software, rerun the same software, the repository of test cases. Make sure you don't really get a red bar, right? That's pretty much right. Right, guys? For what it's worth, I want to make sure everybody really get this idea about regression testing. Maybe back when you were a child, people tell you that when you do reading, regression is not good. Because that means after you have read this paragraph, you will go back and read it again because you forgot about certain detail and keep rereading. That's not good for reading. But for software testing, regression is a very recommended practice. Very briefly, the idea would be you simply maintain a repository of tests over here. JUnit test or maybe some command line test. So somehow this test over here define the correctness. I'll put in quote. Because it's really hard to define absolute correctness. It's only relative correctness. And the idea would be whenever, let's say, you introduce maybe a change to your projects. For example, maybe you want to add a new method. Maybe you want to add some new feature functionality. What should you do? You should do 2 things. Number 1, you may want to extend some additional test to your repository. And number 2, you simply just want to rerun all the tests. That's the regression part, to make sure you don't really get any failure. If you got any failure at this point, most likely it should be injected by the latest change you have done. So the idea would be you want to do regression testing as often as possible, so identify errors. And the Python script I included there is one possible tool you can actually incorporate. But of course, feel free to write your own if you want to. Right? That's about regression testing. It's a very nice practice for you to adopt. Let's see how we can do it. Okay, let me just show you one thing. The only thing you may want to modify. If you go into regression testing folder, you would see, and don't worry too much about ETF. It's more like a legacy name, but feel free to rename it if you want to. Okay? It's actually just from my previous software design course. And you may have to modify this slightly, only one place. Okay? So at least for now. Let me go to Nano. That's just an editor. Use whatever editor you like. Go to that Python code. Okay, pretty short, pretty self-explanatory. The only part you may want to modify. Oh, sorry, I went to the wrong one. Let me do it again. ETF test parameters. That's where I meant to go. If you go there, you will see under acceptance test. So this is more like the repository of tests. There will be another, already a folder called instructor, which means the starter test I gave to you. But you can feel free to create another one, maybe called developer or maybe students, and put as many test cases there as you like as you develop your code. Right? And then, if you go a little bit further, this will be the executable you may have to change. Right? You can feel free to call that my compiler, my solver, or solver, whatever name. So if you change anything other than solver, you will have to modify that, the default. All right? Once you have done that, this is how you can run it. And just remind you about the structure over here. So under the test, if I show you that, you can see this is what you have got. Basically, for each test, you got the test file, the input, and also the expected output, pretty much like the format you were experiencing for the programming test, right? The idea would be start with this initial set of test cases. And if you can pass all of them, that's good, but you may also want to add additional ones to it, also for your projects. There'll be no starter test I will give to you for the project because everybody might design their language differently. But this is where you put your test cases here, as many as you can. That's something I can also put as a bonus criterion for you guys to tell me how many test cases have you ended up with for your project at the end. Okay, how do you run it? Very quickly. Okay, so now we're here. And go into the regression testing folder. And then I think you will have to make this Python script executable, right? For example, you can say change mod, and then to make it executable. You know how to do that, right? And then I'm just going to run it. It's a command. Hit enter. It's going to run basically all the tests. And of course, I'm running the solution version. It simply showed to me 7 out of 7 passed. In your case, unfortunately, in the beginning, maybe 0 out of 7. That's OK. At least you can measure the progress as you go. So that will be some regression testing idea I really hope you will adopt for your assignment 2 and also the project. Right? If you got any trouble running this, let me know. But I think that should be quite straightforward. Just make sure you modify the name in the parameter. All right, any question about this for assignment 2? Are we good? All right, and also adapt this for your project. That's going to help a lot. Okay, that's the first thing I would like to talk about, regression testing. And then for your project milestone number 1, it's actually officially due next week. And let me show to you just as a reminder for everybody. So you definitely want to consult with your team about which time will work the best. Okay? And let me show you this. There's a little change which I think will be nice for everybody. Let me just go to eClass first. Okay. So this is the announcement I made yesterday. So these are the times your team can actually choose. For example, if you choose, let's say 10:30 a.m., of course, on Monday, it's going to be for up to half an hour. Okay? And I think this is something I just decided. I think we can make it a Zoom meeting, but everybody should be there, present. So you guys can share screen. I can also share screen if I have to. I can even record the meeting and make the recording available to you guys. So if you want to refer to my feedback later, you can also do it. I think it's going to be a win-win. So we don't need to be physically meeting together. Unless you guys really want to, you can also suggest. All right, so make sure you talk to your team about which time. I would suggest not just to talk about single time you really want to get, in case other people got it earlier. Think about different alternatives. What's going to happen is I already scheduled some spreadsheets to be activated tomorrow. But I'll show you how it looks like. Okay? Hopefully it's already there. All right, so tomorrow, 6 p.m. precisely, I'm going to send this announcement. And then you will see this link on the Google Doc sheets. And then basically that's all the time that's available there. And you will just have to make sure if that's empty, put all the team members' name over there. That's how you sign up. Of course, if it's already occupied, don't override it, because people might do that to you too, right? Let's be mature. Okay. All right, so that's about the milestone 1 meeting. By the end of Thursday, I will also give you guys just a little bit more instruction. I think it's already pretty clear in the project specification what you're supposed to demonstrate for milestone 1. I'll be even more concrete about what you should do for milestone 1. So you guys can definitely get prepared. It's only 1%. It's not really meant to take out your marks for too much or whatever, but it's really to push you to make progress, right? And also to give you feedback. That's the main intention. All right, any question about this, about the milestone meeting? So we're going to get 2 milestone meetings in total before the final submission, right? Okay, that's about it. And if you guys have no question, so for today, I just want to finish the visitor pattern. I want to talk about the double dispatch. And then I want to revisit about the single choice and open-close principles that we talked about. And we want to just revisit those principles on visitor pattern again to conclude it. And then once it is done, we are done for today. I want to start you guys fresh to go back to top-down parsing. So we're going to talk about 2 parsing algorithms for the rest of the term. And then we might cover more stuff if time permitted. We'll see. But we're going to do top-down and then bottom-up, at least. These 2 are definitely brand new to you. So we're going to start you fresh. Okay. All right, so what I want to do now is to go back to the visitor. Okay? This is where we were from last Thursday about the visitor pattern. Let me remind you very quickly about the architecture. Right? You can see that's the architecture for the visitor. Right? Let me do a recap very quickly. This part here should be no surprise to you. What will be the connection to your Antler 4 project? We definitely got some visitor-based interface that's generated based on your grammar. You can do the hash sign, some name, right? So you can get a corresponding visit method. That's something you did. And also you can create as many descendant classes for the visitor as you like Antler to program, Antler to expression, right? That's the descendant classes we're talking about. And the only part that Antler 4 cannot really generate for you is about the accept method. So this is something we will talk about in the theory in the class, but for you to really 100% exercise the visitor pattern, you may just want to say, for the hierarchy of my programming or testing language, I'm going to define this accept method at the top so that I will be actually implementing the accept method for every descendant classes. Right? That's something I want to emphasize. So for this method here, this will be up to you to actually define, right? Defined by you. All right, that's something you want to pay attention to. And then we are going to talk about how to implement each accept. We actually spoke about it already. It's actually going to be very straightforward for each one of them. You just want to make sure you you call the corresponding visit method. For example, in the case of the constant class, the accept method is going to call v.visitConstant. In the case of the addition, the accept method is going to be implemented by v.visit addition, and etc. Right? That's how you use it, how you implement it. And the final second last bit is to talk about how the double dispatch is going to work at the runtime. That'll be the second last bit. Let's talk about it. Okay, so I'm just going to duplicate this page over here, which I forgot to do. Just bear with me. And then I'm going to start from here for today. Okay, let's now talk about just this particular line. Let's say we have already created this add variable. And add is simply pointing to the root of some expression tree, a simple tree, of course. And a tree has simply a left and also a right. In general, it can be arbitrarily complicated. The left subtree can be itself some expression. And the right subtree can also be itself some expression tree, of course. But in this case, just simple, so we can trace. All right? And also, we got some evaluator objects over here. And the source code has already been made available to you. There will be certain parts I want to highlight as well. I'll do that at the end, after we have done the tracing. So now, how do we trace? Add.accept v over here. Right? Let's now go over that. Oh, sorry, just before that, it might be worth just to brush out your mind. For the constant class, that's a base expression. And we got the accept method here. We simply say visit constant, and then pass the constant itself. And for the addition class, which is a composite expression, like a recursive case. And we still do a very similar line. And here we say v.visit addition. And then we pass this. And if you just one more thing to link back to the diagram. If you look at here, for each visit method over here that's defined in the visitor interface, you can see for constant, we're expecting a constant. For addition, we're expecting addition. That's why you see the this keyword over there to make it work. All right? All right. So that's about this part over here. And what about this part, the visitor? The interface, we explain how many visit methods should be there depends on how many expression classes you actually have in order to visit. Here we got 3. Constant, addition, subtraction. And also, over here, we got visit constant. You can think about it's like a base case for the visit operation. And the visit addition is like a recursive case. And this was a diagram I drew last Thursday. Conceptually, we're going to trace in detail. Conceptually, if I have some expression E, which is addition, we got left subtree, and also we got right subtree. If we want to visit the entire tree, pretty much like we want to apply some recursive operation on the whole tree, what should we do? Well, basically, we want to recursively visit the left subtree, get the result. Also, recursively visit the right subtree, get a result, and put those results somehow together. That'll be the visit result for the entire tree. That's the idea. You'll do something very similar also for your projects if you chose the visitor option, not the action version. OK, so now we are ready to talk about double dispatch. Let's now try to trace this method call. In order for us to trace this method call here, so we got add.accept. This accept method was defined at the top level expression class. So because of dynamic binding, we have to worry about which version of the accept is going to be called. Because accept can be the accept in the constant class, or it could be the accept in the addition class, or it can be many other possibilities. So now in this case, where should we go? Well, if you look at that, add dynamic type is addition. So that means that's so-called the first dispatch. Okay, I'm going to write it down here. The first dispatch is going to be dynamic type of add is addition. What does that mean? That means the version of accept in addition class will be invoked. Hope it makes sense up to now. Right, so dynamic type here is addition, so that means we're going to go for addition. And then when we go for addition here, we go for that accept. And once we go to the accept, the only line to trace is this line over here. All right? And there would be another instance of dynamic binding. Can anybody tell me what kind of dynamic binding is that for the second one? Please. Visitor, yes? Can you be more precise in this case?
Evaluator implementation.
Evaluator for the visitor addition. Exactly. Very good. Yeah. So guys, just to repeat what your colleague just said, which is completely correct. So here, the V over here is dynamically pointing to some evaluator. Oh, by the way, so this structure here is based on the previous page that we spoke about last Thursday. In case you forgot about the detail, you can refer to it. But The V here is evaluator, which is a dynamic type. So this will be the second dispatch. Second dispatch will be, and you can see we are passing the V over here. And the V dynamically is evaluator. Dynamic type of V is evaluator. That means the version of visit addition in evaluator is invoked, which is over here. And you might be wondering, well, you're only showing one version of visit addition. It seems that we have no choice. Actually, you do have choice. Let me just go back to the architecture diagram. If you look at the diagram here, at least for now, we got 1, 2, and 3 different descending classes for the visitor. Right? You can see visit addition here, version number 1, version number 2, and also version number 3. So you do have choices that you have to decide based on the dynamic type at the runtime. That's why there are 2 dispatches you have to make a decision on. Each one is so important. All right? All right, let's now move on. And now we're going to execute the visit addition here, visit addition. That's what we're going to do. And then I'm going to call this method over here. And then the this over here is really the context objects. And the this over here, since we were initially making this particular method call, add.accept v. So the this over here is really the add. Agree? So the addition here is really the ADD, which makes sense, just the top level. So that's our first visit. But things are going to be recursive. So let's see how it's going to work. And let's now trace this part here very quickly. It is so important. All right? But this is a simple case for us to consider. Idea would be we create 2 local variables, both of type evaluator. We got evaluator left, evaluator right. It's pretty self-explanatory. Evaluator left is going to be used to visit the left subtree. Evaluator right is going to be used to visit the right subtree, obviously. Right? Let's say we got these 2 evaluators, and then look at these 2 lines. That's kind of interesting. I'm going to highlight it. E dot left, E dot right. And then notice that we got accept again. And also, we got evaluator also again. All right? Notice the following. We started with add.accept v. And then it boils down into e.getLeft or add.getLeft. Just add over here. Remember, e is simply just add. So get the left subtree over here, let it accept another evaluator, get its result. And then get the right subtree over here, let it accept another evaluator. And each visitor is supposed to store as part of their attribute or state the result. That is why you see in the architecture diagram, we actually got, for each one of them, typically you might just get some public accessor like a result. Of course, you can feel free to rename them if you want to and different types, right? We're only talking about just principle. And for each one of them, again, it's going to be another set of double dispatches. I'm going to do just one more. And then the other one will be exercise for you. All right? For this one here, it's going to be another double dispatch. For this one here, it's just going to be just another one. Every time you want to do some accept on some particular subtree, it's going to be another double dispatch, basically. And let's say for this one over here, we can now practice. Okay, anybody tell me, for this one here, what's going to be the first dispatch? Go ahead, please. What's the first one? Yes. Yes, I agree. But just to be more precise over here, you can see for the first dispatch, I'm pretty sure that's what you meant, but I got to be more elaborate here. This is the context objects for accept. its dynamic type is E dot get left, add dot get left is simply constant. So that's the first dispatch because the dynamic type is constant. All right. So I'm just going to make a quick notes. This one over here has the dynamic type constant, which means we're going to go to the accept of version constant this time rather than addition. And for this accept over here, we're going to call this single line. Here comes the second dispatch. All right? That one should be quite obvious because it depends on what dynamic type it is for V. And V is evaluator left, which is dynamically a evaluator. So that means when we say V dot visit constant here, we are actually going to call the evaluator version. And let's finish that. And if we go to the evaluator version of the visit constant here, that one there will just get the value of the constant itself, because to evaluate a constant is the terminating case, just the value. So that means the evaluated left dot result is going to get this result, which is 1. Evaluated right dot result is actually eventually going to get 2. And then we're going to set a result for the overall evaluator, which will be 3. Right? You can see 1 plus 2, and then will be 3. The result, that will be the V dot result, 3. It's different layers. Guys, hopefully it's not too complicated. Let me summarize what you should know. Number 1, if I give you any example code, you ought to know what will be the first dispatch described in full detail, and what will be the second dispatch described in full detail. Especially when the tree structure itself is actually may not be this simple, right? Feel free to actually create yourself a little bit more sophisticated left subtree and try to use debugger in the Eclipse to see how the double dispatch is going to work. That'll be my suggestion for exercise in preparation for the exam. Okay? I'll write it down here and then to see if there's any further question. Okay, so here, exercise. Make more sophisticated left subtree and trace for double dispatch. All right, that'll be your exercise. Any question about the double dispatch? That's really the essence for visitor pattern. Right? All right, I presume everybody's okay? Right? Okay. The final points about visitor pattern is to revisit this, the design principle, because visitor itself is a design pattern. Being a pattern means it may be applicable in some scenario, but it may also be unpracticable in certain other scenarios. So we ought to know what they are. Okay? And we need an open-close principle to help us a little bit. Okay? So this part we have discussed them already. So that's the final slides. Okay? And let's now just go here. I'll show to you. I want to brush up your memory just about open-close principle very quickly, so you will be able to answer the question. So for the open-close principle, it tells you for your system, let's say in this particular example, we got 2 parts. Structure part for the syntax, the composite, and also we got operations, right? The different descendant classes for the visitor, right? Open-close principle tells you to follow as follows. Some part should be open, and some part should be closed. If you happen to choose, for example, let's say this part over here to be open, that means you are expecting more classes for the expression to be added over here. If you choose the other way, if you choose the operation itself to be open, that means you expect the structure over here to be rather stable. But this part here, you might just keep adding more operations to it. So there are 2 possibilities. And now we want to revisit these 2 possibilities and see which alternative would be suitable for visitor. See what I mean? Okay. Let's now take a look. 2 more pages, and then we are done with the visitor. Let's take a look. Okay, So that's the visitor pattern architecture just there to help you think. Okay. Now, let me just guide you with a question. What if a new language structure is added? Obviously, if we want to add a new language structure, let's say currently we got addition, subtraction. Let's say we want to add multiplication, right? Let's say we want to do that. The fact that you want to add a new language structure, right? So that means you're assuming that the structure is actually open. And the operation part is actually going to be closed. And let's say if you do that, if I try to add a new class over here for multiplication, let me do that first. All right, that's what it means. Are we okay so far? Just about adding a new construct, okay? Before I talk about the consequence, let me talk about the other alternative. Let's say we assume the structure part is closed, but the operation part is open. So that's why what if a new language operation is added? So here we are making a different assumption. So we are saying that the operations is open. And the structure is actually closed. And in order for us to add a new operation, let's say right now we got evaluation, we got pretty printer, we got type checker. What about we got some code generation, for example? Maybe we want to generate assembly code. Okay? That means I'm going to add this class over here. Okay, let me just call that maybe assembly generator. Okay, like that. You can see in one case, we are adding a new language structure because that part is open. In the other case, we're adding a new operation because that part is open. Okay, now, can somebody tell me, as far as the single choice principle is concerned, which scenario is bad? Which scenario violates the single choice principle? That's the question. Once we answer that question there, we will know what will be the exact applicability condition for visitor pattern. William. Okay. Okay, good. Okay, that's very good. Awesome. Okay, that's exactly right. For this one here, think about the consequence. Remember the principle. As soon as we add a new language construct, we have to go to the visit. First of all, we go to the visit interface. We're going to say void visit multiplication, and then something over here. That's the header. Not only that, for every descendant class of the visitor, we have to implement accordingly. So there will be 1, 2, 3, and 4. 4 classes we have to touch to make the change. That apparently violates the single choice principle, which tells you there should be a minimum number of places you really want to modify. So that one violates. And I can tell you in general, if you got many operation classes over here, you got many places to update, of course, whenever you add a new language structure. Okay, so this one here violates single choice principle. This one tells you the following. Visitor pattern may not be good if your language structure over here is actually open. You may not want that. If it turns out your language structure is actually open, you may not want to use the visitor pattern. Because what would that correspond to in the Antler 4? That means you want to keep generating new skeleton code into your Antler 4 projects. On the other hand, you may just want to keep that as stable as possible once it's stabilized. And then only modify the model package, okay, for the operations. All right? So this will be unsuitable for the visitor pattern. And for completeness, let's now talk about the other scenario. Why would that scenario be okay to satisfy the single choice principle? Where would that be? Where would be the single place that we got to modify? Well, apparently, just that class, right? Would that be the only one, to be honest? Would that be it? Well, since there is no language structure to be added, so this one untouched. And we're only adding a new operation over here, right? And all we got to do, we are not even adding any visit method here because there's no new language construct. So all we got to do is create this operation class as a descendant class of the interface visitor, and then implement each of the visit method for the language construct. That's it, a single place. Okay? In this single place, implement all visit methods. That's it. So the single choice principle is satisfied. So if you go back to that slides, which I'm not going to read off the slides, and that would actually tell you, in order for the visitor pattern to be applicable for your projects, the language structure better be closed, but the operation better be open. Right? That's the really concluding remark for the pattern. Okay? And you can definitely go over everything has been discussed. All right. And there's a little bit digression, for our parsing lecture, but now we have covered composite and also visitor. You're definitely more than ready to do a large number of classes in your projects, for sure. Do you guys have any questions? So you'll be okay for me to ask you a question in the exam, right? About composite and visitor, I'm sure. I got some very exciting question for you. Yeah, I'm just saying it, but I haven't thought about it yet. I will think about it. All right, guys, I think as a promise, I'm going to finish earlier today. So from Thursday, we're going to go back to our parsing lecture, and then we'll talk about top-down parsing algorithm. Get ready. All right? I'll see you on Thursday. And for your quiz numbers 2 and 3, I will definitely get them back to you next Thursday, definitely before the drop deadline. Okay? And for your programming test as well, next week.